given each coefficient its simplest form. The expansion can be used to find an approximation to root of 2. Possible value of x that could be substituted into the expansion are. So the first question is to rewrite 1 over root 4 minus x in this format here. 1 over root is basically to power minus a half, and that's what we've done here. So what I've done is I've taken, looking at that function now, I have divided that by 4, now divide that by 4. So that's what I've done here, divided by 4, because what I've done really is I've taken 4 out. When you take 4 out, that means you've divided by 4, you divide it by 4. 4 divided by 4 will be 1, and minus x over 4. Another way to see it is if I multiply the whole thing out by the 4 in the square bracket here. 4 times that will be 4, we cancel 4. If I multiply that by 4, that 4 will be cancelled by that 4. So I get this back. So what I tried to do was take out 4 and try to make that bit here 1. And to make it 1, I had to divide by 4. So therefore, again, that's the 4 now. I'm taking out 4 to power minus a half. That 4 here, that's that. And this one here is 1. Minus x over 4, which is that one, to power minus a half. So 4 to power minus a half is basically a half, because I have got that to power minus a half means that there's a 4 here, so you're going to get 4 at the bottom, you get 4 at the bottom, and then if you root it, that will be 2. So that's why this is a half. Now applying the binomial rule, the binomial a plus b to power of n is equal to a to power of n plus n, a to power of n minus 1, b to power 1 over 1 factorial. This is over 0 factorial, by the way. This is over 1 factorial. 1 factorial is 1. 0 factorial is 1. N into bracket n minus 1. So basically you differentiate that, you get this. So you get n into bracket n minus 1. So that's that times that. That will be n minus 2. That's why it's n minus 2, b squared over 2 factorial. So we need the first 3 terms, where a is 1 in our case, and b is x minus x over 4, and n is to power minus a half. So we just want to replace this one into here. So this is what we're expanding, which is what we go there, and applying that rule here, and the half is just outside the bracket. So I'm only expanding this bit here with that. So I said a is 1, so you go 1 to power of n, and is to power of a half minus a half, plus n, which is minus a half, 1 to power, well, minus a half, minus 1 is minus 3 over 2, and then b is minus x over 4, that's minus x over 4 here. Don't forget over 1 factorial. 1 factorial is 1, plus n here is minus a half. Minus a half minus 1 is minus 3 over 2. 1 to power minus a half, and minus 2 is minus 5 over 2 power. And b squared will be minus x over 4 squared divided by 2 factorial. 2 factorial is 1 times 2, which is 1 over 2. Because you're dividing by 2. If I take that out, it's 1 over 2 factorial, which is 1 times 2. And that's why it's 1 times 2. So this is a half. That a half is here. That 1 to power a half is 1, plus minus x times minus 1 is plus x. And you've got 2 times 4, that's 8. And you've got here minus 1 times minus 3, that's plus 3. Then times x squared, that's minus x times minus x is x squared. So that will be 3x squared. And the denominator here is 2 times 2, that's 4. 4 times 2, 4 times 4. 4 times 16 is 64. 64 times 2 is 128. So if I expand this bracket here, a half times 1 is a half, plus 2 times 8 is 16. So that's x over 16. 2 times 128 is 256. So that's the expansion, the first 3 terms of that function here, or that function. The first 3 terms is this one. So for b, the expansion is valid for, you set the bracket here, the bracket you're expanding to 0 when it's 1 here. So you set that bracket to 0. When you set it to 0, you come to conclusion that x minus x over 4 is 0, which implies that 1 has to be equal to x over 4. But you don't want 1 to be equal to x over 4 because then that will be 0 here in the bracket. So therefore, it has to be x over 4 has to be smaller than 1. Because you can see, if it's equal to 1, you're going to get a 0 value here, which is no good for the expansion. So this has to be less than 1. And therefore, you then say the modulus of x over 4, that means the positive value of this value. The positive value has to be less than 1. So therefore, if you multiply both sides by 4 to cancel that 4, so to find the value of x, times that by 4, and you times that by 4, therefore you're left with x modulus has to be less than 4. For B part 1, where x cannot be equal to minus 14, that should not be used. And for the part 2, as you can see, x can be equal to minus a half. That's what's used. This is the most accurate as it is closest to 0. So this is the most accurate because it is closer to 0.